Hello, I am Gopakumar. Welcome to your math tutor. Here we focus on helping you to solve the problems in engineering mathematics in the easiest possible way from an exam point of view. If you are interested in theory, then check out NPTEL. Before we start doing the problem, we have to become familiar with Cauchy's integral theorem and integral formula. It would be great if you can write down these formulas and also study them. And apart from these formulas, we also need to understand how to draw the given contour. Let us consider mod z equal to 1, which is a circle with center 0, 0, radius 1. It can be represented graphically as shown in figure. Now consider mod z minus 2 equal to 1, which is a circle with the center 2, 0, radius 1. The coordinate 2, 0 lies on the real axis. It can be represented as shown in figure. Let us consider another contour mod z plus 2 equal to 2, which is a circle with the center minus 2, 0, radius 2. Minus 2, 0 lies on real axis. Consider the contour mod z minus 2i equal to 1, which is a circle with the center 0, 2, radius 1. It can be represented as shown in figure, and the coordinate 0, 2 lies on the imaginary axis. Consider the contour z plus 3i equal to 3, which is a circle with the center 0, minus 3 and radius 3. It can be represented as shown in figure, and here the coordinate 0, minus 3 lies on the imaginary axis. Evaluate integral c cos pi z square plus sin pi z square by z minus 1 into z minus 2 dz, where c is mod z equal to 3 using Cauchy's integral formula. In this question, we have to evaluate cos pi z square plus sin pi z square by z minus 1 into z minus 2 over the contour mod z equal to 3. Mod z equal to 3 is the circle with the center 0, 0, radius 3. It is graphically represented as shown in figure. Let us equate the denominator z minus 1 into z minus 2 equal to 0. Consider z minus 1 equal to 0, then z equal to 1. We know that z equal to x plus iy, which is equal to 1 plus 0i. Comparing real part on both sides, we get x equal to 1. Comparing imaginary part on both sides, we get y is equal to 0. That gives the coordinate 1, 0. 1, 0 lies inside the circle. Therefore, z equal to 1 lies inside the circle mod z equal to 3. Let us consider z minus 2 equal to 0, then z is equal to 2. We know that z is x plus iy, which is equal to 2 plus 0i. Comparing real part on both sides, we get x equal to 1. Comparing imaginary part on both sides, we get y is equal to 0, then that gives the coordinate 2, 0. 2, 0 lies inside the circle. Therefore, Z is equal to 2 lies inside the circle. Z equal to 1 and Z is equal to 2 lies inside the circle mod Z is equal to 3. There is an alternate method to check whether the poles Z equal to 1 and Z equal to 2 lies inside or outside the circle mod Z equal to 3 without drawing diagram. Put Z is equal to 1 in mod Z is equal to 3, then mod 1 equal to 1, which is less than the radius of the circle mod Z equal to 3. Therefore, Z is equal to 1 lies inside the circle mod Z equal to 3. Put Z is equal to 2 in mod Z is equal to 3. Then mod 2 equal to 2, which is less than the radius of the circle mod Z equal to 3. Therefore, Z is equal to 2 lies inside the circle. Since Z equal to 1 and Z equal to 2 lies inside the circle mod Z equal to 3, therefore we apply partial fraction. 1 by Z minus 1 into Z minus 2 is equal to A by Z minus 1 plus B by Z minus 2. Here the LCM is Z minus 1 into Z minus 2, and each term in LHS and RHS is multiplied with LCM. The term 1 by Z minus 1 into Z minus 2 is multiplied with LCM, we get 1. And the term A by Z minus 1 is multiplied with LCM, then we get A into Z minus 2. And also the term B by Z minus 2 is multiplied with LCM, we get B into Z minus 1. Put Z is equal to 2 in equation 2, and after simplifying we get B is equal to 1. Put Z equal to 1 in equation 2, and after simplifying we get A is equal to minus 1. Substitute A is equal to minus 1 and B is equal to 1 in equation 1, we get 1 by Z minus 1 into Z minus 2 equal to minus 1 by Z minus 1 plus 1 by Z minus 2. In this question, f of Z is given as cos pi Z square plus pi sin pi Z square. Multiply each term with cos pi Z square plus sin pi Z square. We get cos pi Z square plus sin pi Z square by Z minus 1 into Z minus 2 equal to cos pi Z square plus sin pi Z square by Z minus 1 plus cos pi Z square plus sin pi Z square by Z minus 2. And now we are going to integrate using Cauchy's integral formula. Integral C f of Z by Z minus Z naught dz equal to 2 pi I into f of Z naught. Here f of Z is equal to cos pi Z square plus sin pi Z square. Integral cos pi Z square plus sin pi Z square by Z minus 1 into Z minus 2 dz equal to minus integral of f of Z by z minus 1 dz plus integral of f of z by z minus 2 dz. Substitute z naught equal to 1 and z naught equal to 2 in Cauchy's integral formula, then first term becomes minus 2 pi I into f of 1 plus, and second term is 2 pi I into f of 2. F of 1 is equal to cos pi plus sin pi. Cos pi is minus 1 and sin pi is 0, then we get minus 1. Applying z is equal to 2 in cos pi z square plus sin pi z square, then we get f of 2 is equal to cos 4 pi plus sin 4 pi. Cos 4 pi is 1, sin 4 pi equal to 0. That gives 1. 2 pi I plus 2 pi I equal to 4 pi I.